Okay, butterflies, today we're going to talk about multiplying and dividing by base 10 numbers. Multiplying and dividing by base 10 numbers. So this is really good. And base 10 numbers are the foundation of making math really easy peasy lemon squeezy. So do me a favor, and I really appreciate doing the videos for my sweetie pies, my honey bunches of oats. So do Miss Norma a favor and go and give me a like. And if you can, subscribe to my videos. Okay? All right, let's get started, buddies. First, we're going to talk about what base 10 numbers are. Okay? So base 10 numbers are any numbers that can be divided by 10 evenly. Okay? And also base 10 numbers end in the number 0, right? These make all operations so easy, so lemon squeezy. You know how you build a house and you have to build a foundation first, and then after that, then you set the next level. Then after that, you can set the next level. So base 10 is usually the foundation for really easy peasy lemon squeezy math. So let's talk about some base 10 problems. Okay, so base 10 problems. Remember, base 10 numbers can be divided by 10 evenly. Okay, and then they also end in 0. So I'll take my base 10 number. Here I want to put another number first. If I had 2 times 10, which one of these numbers will be my base 10 number? Well, I hope you said 10, right? Because it can be divided by 10 evenly. 10 divided by 10 equals 1. No remainder, right? And, buddies, another check mark here. It ends in 0, so we know that it is a base 10 number. How you would multiply this really easy. You would say 2 times 1, which equals 2, and then you move your 0 over here. So if there's 1 0 over here, I'll put 1 0 over here, and the answer is 20. It works the same way, even if the numbers get larger. So let's try to make the numbers larger. What if I had 2 times 200? Okay, same thing. I will multiply 2 times 2, which is 4. Count the zeros, 2 zeros over here, so I know I add 2 zeros over here. So 400 would be our answer, right? What if I had 2 times 20,000? I skipped 2,000. 20,000. I would multiply 2 times 2, which equals 4. And then I would count the zeros, 1, 2, 3, 4. And I would add 4 zeros over here, 1, 2, 3, 4. So the answer would be 40,000. Very good. So some of you might say, well, Miss Norm, what if you got a double-digit number? Well, let's try it. Because if we have a double-digit number, we just have a double-digit number. As long as we are multiplying by a base 10 number, it's really easy lemon squeezy, okay? So here, what if I have 12 times 2,000, okay? I would multiply 12 times 2, which is 24. And then count the zeros, 1, 2, 3, 3 zeros behind it. So the answer would be 24,000. It works the same way. As long as you're multiplying by a base 10 number, it works exactly the same way. Now let's talk about dividing by base 10 numbers, because multiplying by base 10 numbers, you count the zeros and add them to the other side, right? Well, dividing by base 10 numbers, little buddies, we kind of do the opposite here, right? So let's see. What if I had 20 divided by 10? Okay. I would count how many zeros are here in this base 10 number. And then I would eliminate however many zeros I take away over here. That's how many zeros I can take away from here. And so the answer would be 2. Okay. Because 2 divided by 1 equals 2. 2 divided by 1 equals 2. All right, let's go to another example here. What if I had 200 divided by 10? I would count how many zeros are on the right. Here in my base 10 number, I have 1 0 here, so that means I can eliminate 1 0 there. And the answer would be 20. 20 divided by 1 equals 10. Now, what if I don't use the base 10 number 10? What if I have a number or a problem that says 200 divided by 20? How do we do that? The same way, butterflies. I want you all to know it's the same exact way. Base 10 numbers, really easy, really lemon squeezy, okay? So I would count how many zeros are in this base 10 number, 1. So that means I can eliminate 1 0 over here. And then we just do our operation. 20 divided by 2 equals 10. Let's go larger, just in case, okay? To show you that it works with all of these numbers, okay? Let's do 4,000 divided by 200, okay? Same thing, same format. I would count how many zeros are in this base 10 number. 1, 2, okay? That means I can eliminate 2 zeros over here. And all I'm left with is 40 divided by 2. So 4 divided by 2 equals 2. And I add this 0 at the end. 40 divided by 2 equals 20. Which really means 4,000 divided by 200 equals 20. So yay, base 10 numbers, yay. We did pretty good on that. Can I show you another little trick here? It not only works with whole numbers, multiplying and dividing with base 10 works also with decimals. So what if I had a decimal, Miss Durham? You didn't tell me about decimals. Yes, I am. I'm going to tell you about decimals right now. Here we go. I'm going to tell you about multiplying and dividing decimals. So let's work with a decimal, 1.7. And I wanted to multiply that by 10. Same thing, I would count how many zeros are here, except for we're not adding any zeros yet. We want to move our decimal, okay? So you see this decimal we have here? Only thing we would do is move the decimal. Very good for Miss Durham. So however many zeros you have in your base 10 number, that's how many times you're going to move your decimal, right? So here I have 1 0 in my base 10 number. So I'm going to move my decimal one place. But where? Which way do I move it? Do I move it to the left, Miss Durham? Or do I move it to the right, Miss Durham? Now, let me give you the clue. This tells you which way to move your decimal. If the symbol is multiply, when you multiply numbers, they get bigger. Right? When you divide numbers, the answers get smaller. Right? Let's talk about it. When I multiply 2 times 2, the answer is much bigger than the 2 we started with. But when I divide, 2 divided by 2 equals 1, the answer is much smaller than the numbers that we started with. So when you multiply, the answers get bigger. When you divide, the answers get smaller, right? So remember that multiply, things get bigger. Divide, things get much smaller. Multiply, things get bigger. When you divide, things get much smaller. So since this particular problem, we're multiplying, and our symbol is multiplying here, we have to move the decimal where the answer gets bigger. So let me move this down. Okay. Now, which way do I move this decimal to where the number will get bigger than it originally started with? Let me try to the left. Okay. Now, is 0.17 bigger than 1.7? No, not at all. Very good. So that's the wrong way, right? Now, what if I move the decimal? Because remember, we're moving one place to the right because I have 1 0 in my base 10 number. Now, what if I move it one place this way? Is 17, the whole number 17, is that bigger than the number 1.7? Yeah. I wish I had sound effects. Yeah. Let me try. Yay. 17 is bigger than 1.7, so we know we moved the decimal the correct way. So here, 1.7 was our original number, times 10 equals 17. Got it? Get it? Okay, good. Let's try one more, so I can make sure everybody has it, right? Let's try another one. Let's try 1.7, okay, times 100. Yeah, this is going to get a little different. It's getting juicy. We're getting smarter. Your brain should be hurting. We're getting so smart, right? All right, first thing we do is count how many zeros are in our base 10. We have 2 zeros there. So I know I'm going to move my decimal 2 places to the right? Because I have the 2 zeros in my base 10 number. So let's get ready to move our decimal. And I know I'm going this way. Hold on, let me get that back. I'm going to jump this way because I have a multiplication problem. The number has to get bigger. When we multiply, you move the decimals where the number gets bigger. So 2 zeros here. I'll move the decimal 2 spaces. Come on, decimal. Here we go. 1, 2. I place the decimal there. Now, what happens with this empty space? What do you think happens with that empty space? I hope you said add a 0. Very good. You add a 0. You fill in those empty spaces with your 0. Now, the answer is 2,170. So, 21.70 times 100 equals 2,170. Yes. I feel like I need to do it one more time. I really want to move on to dividing decimals because it works the exact opposite. Let me erase here. Okay. Let's try some dividing decimals. All right, buddies. Let's do the same ones we did before. I think it was 1.7 divided by 10. 1.7 divided by 10. The same thing here. I count how many zeros are in the base 10 number, right? And then I move the decimal, okay? However many zeros I had in my base 10 number. Here we have 1 0, so I know I'm going to move the decimal one space. But I have to move the decimal this time to where the number would get smaller because we're dividing. When you multiply, the numbers get bigger. When you divide, the numbers get smaller. So here I'm dividing. I have to move the decimal where the numbers get smaller. So let's get ready to move our decimal. Okay, I have 1 0 on my base 10 number. I'm going to move the decimal one space and where the number gets smaller. And our new answer here is 0.17. So 1.7 divided by 10 equals 0.17. We did very good. Good job there. Very good. All right, let's go to the next number. We have 2. I believe it was 1.7. Let's do 1.72. Okay. Divided by, let's do 100. Okay, 1.72 divided by 100. First thing I do is count how many zeros are in my base 10. Then I look at my division sign or my symbol, my math operation symbol. This one is division, so I know I must move to the what? We're moving to where the number gets smaller, which means we're going to move to the left. So let's move. 1, 2. Replace the decimal there, and the answer is 2,172. 10,000s, right? Very good. Good job for us. That's it, buddies. Do you all need some more? One more? You want one more? All right. Do you want division or multiplication? You want decimals or do you want... So give me a comment below. Comment and tell me which problem you want me to do, for example. Comment and let me know if you need any help. And don't forget to give me a like. Don't forget to give me a like. Guess what? Don't forget to give me a like. And always, buddies, I need some subscribers. Okay, Miss Storm loves you. Happy learning, you all. Bye. See you, buddies. I see you. I'm going to miss you.